Let's talk tech. Exploring tech together.
All right, today we're tackling a really critical challenge that pretty much any company jumping into AI is facing. How do you manage the chaos? We're going to look at a case study of how this one global appliance leader built a platform to get its AI traffic under control, turning what was a huge bottleneck into a real strategic advantage.
So, think about it for a second. Your company is adopting AI, which is awesome. But who's directing the traffic? It's so easy to get excited, right? Different teams start spinning up different AI models, and before you know it, you've got this massive digital traffic jam. Who's actually in control? Who makes sure things run smoothly? This is a problem a ton of companies are running into, but not many have figured out a solid solution yet.
And yeah, this is exactly what the AI boom looks like on the inside of a big company. It's usually not some single coordinated push. Nope. You've got R&D over here using coding assistants, marketing's over there generating content, and the product teams are trying to embed AI into actual appliances. And it's all happening at the same time. A lot of times, they're even using different models from totally different providers. It's basically a recipe for some serious complexity.
But all that excitement, it creates some serious new bottlenecks. I mean, it's the inevitable result, right? This super fast, kind of uncontrolled growth leads straight to fragmented traffic, chaotic scheduling, where different models are basically fighting each other for resources. And this is the worst part, costs start spiraling and things get unstable. It's a classic case of growing way too fast without a central game plan.
Okay, so let's get into the 3 core infrastructure challenges. Faced with all this growing chaos, the infrastructure team basically had to hit the pause button. They knew that to build a real solution, they first had to get super clear on what the problem actually was. So they broke it all down into 3 core challenges that absolutely had to be solved right at the infrastructure level.
All right, so here are the big 3. First up, stability assurance. How can you guarantee that every single AI request is going to be stable and can bounce back super fast if there's an error? Next, multi-tenant isolation. This is a big one. How do you stop, say, the marketing team's AI agent from going haywire and crashing the services for the R&D team? You got to keep them separate. And finally, intelligent scheduling. You've got a mix of your own private models and public cloud ones. So how on earth do you route all that traffic in the smartest, most efficient way possible?
And this became their North Star, their guiding principle. They realized that AI traffic has to be uniformly governed, visually monitored, and intelligently scheduled. Every single piece of the solution they built had to check these 3 boxes. See, it's not enough to just open the floodgates and let the traffic flow. You have to govern it, you have to watch it, and you have to schedule it with real intelligence. This simple statement, it became the bedrock for their entire platform. So what was the blueprint for this solution? Well, they landed on building an enterprise-grade AI gateway. What they did, which was pretty smart, was build on top of their existing API gateway. They essentially transformed it into this unified, intelligent hub built from the ground up to handle the very unique demands of AI traffic.
And they built it with this really elegant 3-layer architecture. Let's break it down. First, you have the access layer. Think of this as the single front door for absolutely everyone. No side entrances. Then there's the governance layer. This is the rulebook. It handles all the important stuff like routing rules and security policies. And finally, you've got the scheduling layer. This is the real brain of the operation, automatically switching traffic between different models based on their health and how much load they're under.
All right, so that's the blueprint. The theory is solid, but how does this thing actually work in the real world? Let's jump into a couple of scenarios to see how this gateway's smart routing really solved their biggest headaches. Okay, scenario 1, automatic fallback for high availability. This is a classic, right? And it's absolutely critical. You have to make sure your most important AI services are always on. I mean, what happens if your main model goes down? You can't just leave your users, or in their case, their smart appliances, completely high and dry.
So their solution was this really clever hybrid model fallback strategy. On one hand, they have their primary model. This is when they built themselves, running in their own private data center. It's cost-effective and handles all the core traffic. But, and this is the key, they also have a backup model. This one's a public cloud service with pay-as-you-go pricing. So if that primary model gets overloaded or, worse, just fails, the AI gateway automatically, and I mean instantly, reroutes all the traffic to the backup. The best part? For the ops team, it's totally seamless. They don't have to scramble and flip a switch. They just get an alert that the failover happened. Problem solved.
All right, let's look at scenario 2, token-based rate limiting.
This is all about managing resources fairly. See, just counting the number of requests someone makes is actually a really bad way to do it. Why? Because one single super complex request can eat up thousands of times more resources than a simple one. The real currency in the world of large language models is tokens. You can think of them as pieces of words. And measuring usage by tokens is a much more accurate way to see what's actually going on.
And this table just shows their solution perfectly. The AI gateway isn't counting requests, it's counting tokens. So you can see here for LLM-A, each consumer, let's say these are different business units, gets their own specific quota of tokens per hour. Consumer A gets 10,000, consumer B gets 20,000, and so on. But, and this is super important, there's also a global limit for the model itself, in this case 50,000 tokens. The gateway checks both limits. So even though consumer B is the biggest user, they can't just hog all 50,000 tokens because they're capped at their own 20,000 quota. It's a brilliant way to ensure fairness and stop any one user from bringing the whole system to its knees.
So, after all that work, what was the real value? What was the payoff? Let's start to wrap this up by looking at what the AI gateway actually delivered, and, maybe more importantly, where this company sees the whole thing going in the future. Honestly, the results were pretty transformative. There were 3 key achievements. First, they totally simplified access to large models. Developers could now just call any model they needed through one single entry point. That lowered the barrier to entry like you wouldn't believe. Second, centralized resource management. This meant they stopped wasting money on duplicated GPU infrastructure all over the company. And finally, unified control and traffic security. By having one single choke point for all AI traffic, they could suddenly implement unified security, auditing, and content filtering across the entire platform. Huge wins all around. But the vision here is so much bigger than just being a smart traffic cop. They're looking at this AI gateway evolving from a simple distribution node into the AI kernel. I mean, think about that. The scheduling core for the entire AI capability system. It's like it's becoming the foundational operating system for everything AI in the company. It's not just directing traffic anymore. It's the core that manages all AI capabilities. And in the end, it all comes back to this one powerful idea. The ultimate goal is to make every single AI request observable, schedulable, and governable. That's the end game. What does it really mean to be in control of your enterprise AI? It means that every request from every user to every model is something you can see, something you can schedule intelligently, and something you can govern with your own rules. It's all about taking that initial chaos and turning it into a finely tuned, super powerful, and totally reliable system.